right, following that up, we've got Noah Stride. Noah is a software engineer with years of experience building platforms and tools based on cloud-native tech to unlock the productivity of other engineers. At Teleport, and this is what he's going to be talking about, he leads the Machine ID team, which hopes to bring ease and security of the Teleport platform to machine access. Please welcome Noah.
Okay, welcome to Machine ID, a whistle-stop tour. Thank you all for coming along. I hope you had a good morning so far. I'm hoping to kind of cover what Machine ID is, how it works just a little bit, and why your organization might want to adopt Machine ID for your machine-to-machine access. As I was brilliantly introduced, I am Noah Stride, and I work here at Teleport, leading the efforts on Machine ID. I've been here for around 2 years, just as long as Machine ID has been a product we've offered. And if you've been trying Machine ID or you've had problems with Machine ID, you may well recognize me from Slack and GitHub interactions. Before we can talk about Machine ID, we have to talk a little bit about the space that it operates in, and that is machine-to-machine access. Machine-to-machine access, we have to talk about what is a machine. And we're no longer talking about that physical box we keep under our desk or in a server rack somewhere. We're talking about virtual machines. We're talking about containers and IoT devices. And now, these days, we're even talking about serverless. It may well be easier to just describe a machine as something that runs a workload, whether that be an API or some kind of other automation that you've developed. For it to classify as machine-to-machine access, it also needs to be non-interactive. If I was to take my machine, this laptop, and SSH into a server, we're not going to call that machine-to-machine access, even though it's a machine connecting to a machine. And that's because I, a human, am driving the process, and we're able to use my credentials in order to connect to that. To give a more concrete example, we can give the case of CI/CD. An engineer makes a commit and pushes it up to your source control software. That'll go off and trigger your CI/CD runner to go and do some actions. It may, as part of your CI/CD process, connect out to your fleet of servers and push up your latest Docker image or binary. That segment between your CI/CD runners and your servers is your machine-to-machine access, and we need some sort of credential to be used there. An engineer may have started the process, but an engineer is not sitting at your actual CI/CD server running each of the commands that is going to be run. So, typically, the way we solved this previously is perhaps we'll write some long-lived credentials out to disk on the machine that is going to be doing the access. These might be API keys or passwords, and likely they either have an expiry date far in the future or they don't expire at all. We might think, oh, that's a problem. We don't want these, powerful credentials just sitting on disk. So you may end up using a secret store offered by your CI/CD provider. But as we've learned, that's not bulletproof. At the start of this year, CircleCI warned all customers that there had been a potential exfiltration of credentials stored in their secret store. So the real problem here isn't how you handle long-lived credentials, but long-lived secrets themselves. No matter what you do, you're always going to have problems. You might even be aware of these problems and decide to mitigate them by rotating these credentials regularly. But how many of you have committed to, renewing these credentials regularly and then finding a year or 2 years later that that rotation has never happened? What makes all this worse is the ways in which machine access is different to human access. Machine access is wider reaching. An engineer might only be expected to connect to a couple of your servers. But if you're using Ansible to manage your entire fleet of Linux hosts, that host that's running your Ansible is going to have access to all of them. Machine access is typically more privileged. Your engineers might start off with only the ability to connect to a machine and read some log information. You might even be using teleport and access requests to request more privileged access when it's required. But your CI/CD platforms are going to require some level of privileged access in order to deploy new versions. Finally, machine access presents a greater volume of logging. A human may only be able to connect to so many servers in a day, as fast as their fingers can move. But your CI/CD systems and other automated systems may well be capable of connecting to your entire fleet of thousands or tens of thousands of servers in only a couple minutes. This activity in the audit logs provides really great cover for malicious activities. If those credentials are exfiltrated, the malicious activity will be hidden under the legitimate activity of the machines. Combined, this makes those long-lived secrets a highly sought-after target for bad actors. So what can we do about that? Introducing Machine ID, Teleport's solution to this problem. We kind of saw the question, teleports, might be the easiest and most secure way for your humans to access your infrastructure, but can we take the technologies that power teleport and use them for machines too? Machine ID provides an identity-based solution to machine access, with the concept of a bot being introduced. A bot is to a machine what a user is to a human, and they share many of Teleport's existing features, whether that be their access being controlled by roles, or their access being audited in our auditing log. To actually use Machine ID, we offer a binary called tbot. tbot looks after the process of fetching short-lived credentials for your other automations to use, whether those other automations be using tools like OpenSSH or tools like kubectl. tbot will handle authenticating with your teleport cluster and then requesting the signing of these short-lived credentials that will be needed by your other tools. These credentials can then be written out to disk or even to Kubernetes secrets. We refer to this generally as the destination. The clients like kubectl or OpenSSH can then read those credentials from the destination and use them to connect out to your teleport protected resources. In addition to just writing credentials, tbot also writes a bunch of helpful configuration files. You may not want to work out yourself how to configure OpenSSH to use those credentials. So we'll write out an OpenSSH compatible configuration file, and similarly for Kubernetes, we'll write out a kubeconfig file. This entire process can run in the background and with some regularity. Since we're writing short-lived credentials, if you need your access to be kind of longer-lived, you've obviously got a problem if those credentials only live for half an hour, say. So tbot will run in the background and continually update those credentials. Now you might be thinking, but how does tbot authenticate? I've already talked about how awful these long-lived secrets like passwords are, but if tbot just needs a long-lived secret, then surely we're just falling into the same trap. The good news is rather than logging in with SSO or a username and password, things that aren't really natural for a machine, bots join using a join token. If you've configured teleport before and you've deployed our agents, you'll already be aware of this joining process. The join token configuration resource sets out the rules for this joining process. It defines which method will be used to authenticate and any additional requirements you want to enforce during that joining process. The class of join methods we refer to as delegated allow an identity token signed by a workload platform to be swapped for a teleport identity. But what does that mean? Typically these days, as platforms become more advanced, workload platforms like AWS or GitHub Actions or GCP, they offer your workloads a sort of signed ID token signed by their platform's private keys that contains information about your workload. Information like the name of the virtual machine or in which region it's running. Since these are signed using public key cryptography, the teleport auth server can trust the contents of these ID token JWTs merely by validating their signature with the well-known public key. This is what allows the join token to enforce those additional requirements. You can say something like, hey, I want this bot to be able to join, but I only want it to be able to join from this GitHub repository and running with this workflow. In total, this process eliminates the need for those long-lived shared secrets that are causing us so many problems in the first place. So now we know a little bit about how Machine ID works, it's useful to think about the benefits we derive from that. The first benefit that I think is the most important is not a technological one, but a soft one. By unifying your access control for humans and machines, you can achieve consistency in policy. You may well be an organization that is audited in some way, and as part of passing your audit, you'll need to prove that you review the access granted to your human engineers every so often. You might not be completing this process for your machine access as well. It might not be required by your audit. But by bringing machine access onto the same platform, when you review your human access, it only becomes natural to review your machine access. And that kind of consistency in policy is only going to reap benefits. You're all here at Teleport Connect and surely know a little bit about Teleport. By using Machine ID for machine access, you're reusing all that existing knowledge of Teleport features you love, whether that's how to define your roles or how to use our locking systems and access requests. Machine ID outputs short-lived rotating credentials, which means that if those credentials are to be exfiltrated, the amount of time that a malicious actor has to use them is limited. As we covered, the delegated joining eliminates the need for long-lived shared secrets on supported platforms, getting rid of those secrets that are causing us so many problems in the first place. Finally, you may well be aware of Teleport's connectivity plane. Your Kubernetes clusters and virtual machines that are on private networks that may not be accessible to other things can be accessed through Teleport, using our Teleport proxy and our tunnels. This is great in the case of using hosted runners on platforms like GitHub. You may not want to whitelist all of their IP addresses to be able to connect to your clusters, and going through Teleport means that that process becomes natural and easy. So, what are people actually using Machine ID for? I can talk a lot about the benefits, but it's useful to kind of look at what are the existing customers enjoying with it. The first one, as I've talked a lot about already, is deployment. Probably 60 to 70% of the usage of Machine ID at this time is in organizations for deployment. They're deploying from platforms like GitHub Actions, GitLab, CircleCI, and a bunch more. They're deploying things such as applications to Kubernetes clusters using tools like Helm, or they're managing the configuration of a fleet of Linux hosts over SSH with tools like Ansible. You can even manage Teleport's own configuration. If you're an organization that's all in on infrastructure as code, you may be well aware of our Terraform provider for managing your Teleport roles and other forms of configuration. Obviously, that Terraform provider needs some way to authenticate with the Teleport API, and Machine ID can step in and ensure you're using short-lived credentials for that. The next case we're seeing a lot of use for is security scanning, and I've put here who watches the watchman. But my point here is that your scanning tools often have access to your infrastructure widely across your whole organization. If you're using a tool like Trivy, which scans Kubernetes clusters, it needs access to all your Kubernetes clusters in order to be able to connect to them and analyze them. If the credentials for your security scanner are exfiltrated, suddenly a bad actor has access to all of your clusters. And that's a problem, right? You don't want your security tool that you're hoping to improve your security to be the start of your next breach. So using something like Teleport and Machine ID means that those credentials can be short-lived, and you benefit from Teleport's audit log being able to spot any potential malicious activity. The final use case I'll talk about is custom automations. Teleport offers an API and a Go SDK for that API. You may already be using this in your organization. It's a fantastic way to tweak Teleport for your organization's workflows, and really, your imagination is the limit with what you can build with this. This, of course, again, requires a way to authenticate with the Teleport API, and Machine ID is a really natural way of doing so. So those are the 3 use cases I've talked about, but really there's a whole bunch more. Any case where you're having a machine accessing a machine, and that machine it's accessing is currently a Teleport resource, it should be a great fit. Next, we'll try and do a demo if we're lucky. I'll be showing, as I've talked a ton about deployment and kind of it's the most natural use case, we'll be looking at deploying to a Kubernetes cluster from GitHub Actions without the use of long-lived secrets. So we're working for a hypothetical organization. Our product is a HTTP server that displays a colored web page. It's highly advanced, and we're making sure we're using all of the best security practices. This is hosted in our Kubernetes cluster on Google Cloud. It's fairly simple and just exposed by a service. Our Kubernetes cluster is enrolled in Teleport. Colormatic is an organization that loves Teleport. And all the code for this application is stored in GitHub, and we're using GitHub Actions for deployment. We can see that our last deployment was 2 hours ago. Let's take a little look at the actual code. So the actual code for the application is fairly simple. If you know Go, there should be nothing surprising here, and there's nothing special Machine ID in here. But to demonstrate that this whole thing works, what we'll do is we'll change the color from green to blue. And hopefully that'll run and succeed in the background while I'm talking. So the first thing to go back and look at is that within our repository, we've not actually configured any secrets here at all. And I just wanted to make a point of that because I think this is one of the really big selling points of Machine ID, is there's not any secrets configured, and there's certainly no plain text variables configured either. When we go back to the actual implementation, we'll first take a look at the join token that I've talked about. We talked about join tokens earlier in terms of that kind of secretless initial authentication to the teleport cluster for the bot. This is the token that's in use. I've defined the join method as GitHub, which tells the teleport auth server that we're expecting a GitHub formatted ID token from the platform. We configure the allow rules to say which identities from GitHub will be allowed to authenticate. You can configure as many allow rules as you want here, and as long as one of them is passes, it'll be able to connect. Here, we've just done one. I specified the repository I'm expecting the workflow to be running in, and I've also specified that I expect that workflow to be linked to production. This is a feature of GitHub Actions you might not be aware of, but it's possible to essentially link a sort of a workflow within your CI to a specific environment, and it allows you to then enforce additional requirements, such as being approved by certain users. We can now take a quick look at the actual workflow itself. GitHub Actions uses a YAML format for configuring its workflows, and it's fairly simple. In the first step of our process, we're just going to build and push a Docker image. There's nothing special or machine ID going on here. But this is where the magic happens, the deploy to Kubernetes step. You'll note here that the environment has been set to production, and this means that the token issued by GitHub to the workflow runner that's running this workflow will contain that production claim. And therefore, when we go back to our join token, when the teleport auth server is handling that initial authentication, it'll say, hey, that's good, it's set up against production. The workflow starts off by installing all of the necessary tools, and then calls our off-the-shelf teleport actions auth-k8s GitHub action. You don't have to use these actions, but they basically are a thin wrapper around the tbot binary and configuration file, and just helps make it more natural within a GitHub Actions flow. You can see we specify the name of our proxy, as well as the name of the token that we wish to use to connect. We've set a super short TTL here. Since we don't expect our workflow to run longer than 10 minutes, we can make sure that those certificates can only be used for 10 minutes. We've specified which Kubernetes cluster we want to generate credentials for. And finally, I've enabled the anonymous telemetry. Finally, we move on to the Azure K8s deploy action. This action is just using kubectl under the hood. It's been automatically configured by the previous action to use the credentials that have been written to disk. This means that whenever this kubectl is run, it's going to be running against the cluster that we've specified up here. With any luck, if we head back over now, we should see that this action has succeeded in running. If we take a little look, we can see that the deploy Kubernetes manifest step has run and succeeded on all steps, and we can even see in the tbot logs that it's generated credentials for the cluster GCP. If we head over to GKE, we can hopefully see that the latest deployment has rolled out with our latest revision of the software. Yep, just a few minutes ago. Finally, no, the proper test, let's check if the color's changed. Great, it's blue. That's exactly what we're looking for. Now, it's all cool. I mean, we've seen that we've done that without secrets, and that's pretty great. I mean, that's a great thing we should be proud of. We know we've done that whole thing with no secrets. That's great. There's nothing to be stolen. But there's a couple other benefits that we're getting from Teleport during this process. First of all, our audit log. If we head back to Teleport and we head back to management, we can then open up the audit log. And hopefully, we'll see the Kubernetes requests that were fired off by our bot. Let me just increase the size a little bit. Great. So these are all the sort of Kubernetes requests that we are expecting to see when something's deploying to Kubernetes. It's fetching a bunch of stuff and then patching a bunch of stuff. These contain all the normal information you'd expect to see in a Teleport Kubernetes access audit log. The kind of really interesting bit is this bot joined event. Now, remember how I was talking about that ID token issued by GitHub that kind of contains all that information we can trust? That information is all within this bot joined event. And that means we can trace back those Kubernetes access audit logs to which exact GitHub Actions run was responsible for what occurred. We can see here run number 38. We can even see the commit SHA that's responsible. And this is really powerful in terms of, if you finally see something in your audit logs that looks wrong, or your SEIM catches something that looks wrong, we're going to think, hey, we need to work out what's caused this action. You could take here, you could see, okay, run number 38. hop back over to your GitHub Actions and say, hey, that was StrideNet. Let's take a look at the commit and see what's caused that. You may well find that this is a commit you're not expecting your engineer to make, and you may need to shut down his access and act quickly to kind of prevent any further damage. Okay, great. So that's all for the demo. And let's have that full screen so we can actually see. Great. So what's next for Machine ID? So first of all, we talked a lot about kind of the workload platform integrations in terms of the delegated joining. We support a bunch of the most popular platforms on the market at the moment, but there's a couple more we need to support. If you're in an organization and we don't currently support the platforms we're using, please do let us know and we'll make sure we can get it on the roadmap. Second, we want to improve support for dynamic use cases. This isn't something I've really covered much so far, but at the moment, Tbot is relatively static in its configuration. Before you start it, you set it up and you say, hey, I want to generate some credentials for this application, or I want to generate some credentials for these Kubernetes clusters. This is great for most simple CI/CD use cases, but we've had a couple customers who are trying to do much cooler stuff. For example, their automation decides on the fly which of their thousands of servers they want to connect to. There's a couple workarounds for this, but they're not fantastic, and we really want to improve the support for this because we think it's super neat and something that we want to fall within the purview of Machine ID. So what that will likely look like is offering an API that can only be accessed locally for applications to call to request credentials they need as they go. Finally, I want to improve the management and monitoring experience. You may have noticed that currently in the Teleport UI, there's no kind of distinct bots panel. You can manage them with tcuttle, but that's not fantastic. So I'd love to kind of introduce that, have like a proper flow, make it way more discoverable. Next, I'd love to improve the infrastructure as code experience. We do currently support bots in the Terraform provider, but I think there's a lot more we can do to make that experience even better. And I'd like to add heartbeats. You may be aware at the moment that Teleport agents send up a heartbeat every so often to the Teleport cluster, and that includes things such as what version is running, if it's healthy. And that's great for if you want to step back from your cluster and work out, hey, which of my nodes do I need to update? I'd love to provide the same experience for Machine ID. That is all I have on that. Thank you very much. I apologize for being severely jet-lagged. Do we have any questions?
How much time do we have? Okay. My question are pertaining to two types of machines. The first type is about IoTs, including industrial IoTs. Just wondering, how do you solve the classic problem? Onboarding the machines, categorize them, manage this profile, understand what kind of machines can do what.
So yeah, the initial authentication is always going to be that really big problem. And then on these kind of really popular workload platforms, we have the option of those identities provided by the platform. But when we're talking about these small IoT devices, that's not something we've got. So we do end up with the same problem. But there's a couple options we have there. One of the things I'd like to look at down the road is kind of TPMs and sort of hardware enclaves, and the ability to essentially enroll the device at manufacture time within your Teleport system and say, hey, I trust this device ID, we know about the TPM, and then use that as a form of authentication. And that, again, sort of eliminates the need for a long-lived secret. Of course, the secret does exist, but it's within the TPM, so hopefully should be secure.
Okay. Second part is that, do you support non-HTTP protocols?
Yes. So in terms of accessing things from that machine to, yeah.
In our case, it would be Blu-rays, Wi-Fi's, MTTQ, those kind of stuff, and LoRa as well. Yeah.
Yeah. So I know we support TCP application access. I'm a little bit unsure about other protocols. It's something that we'd have to follow up on, I think.
Okay. Yeah. I'd love to see vendors support more of those non-HTTP protocols because that's still a challenge for us. Okay. Second part question is switching to API clients. Should be easy answer for you, I guess. So again, can you talk about how do you allow API clients, especially external API clients, to register, get this join token to access the backend API services?
So if I'm understanding correctly, the join token is essentially something that's configured by the administrator of the Teleport cluster. It's a little bit poorly named. It's pretty easier to think of it as sort of like a guess, configuration or like a profile. It kind of describes the joining process and the rules that need to be enforced, and then the joining devices can specify which of those profiles they're using. I'm not quite sure I understood the...
Okay, I'm just trying to figure out where this machine ID solution fits into the API world. We have API clients calling to our own API services. We have the same issue, right? We need to identify API clients. We need to give them access. We need to authorize their access. I'm looking at API Gateway. API Gateway do a good job for API authorization, but what about API authentication? Does this solution fit in here?
So that's kind of an interesting one, because Teleport sort of provides a lot of the connectivity side that's necessary, especially if you're reaching like an API that's hidden and coming from perhaps like some IoT devices or something. You'd be going through Teleport application access to grant access to those APIs, which is perhaps something not I'd recommend today, to be completely honest. The Teleport proxy is really performant for human access, but if you're doing something like an API, we're expecting like thousands of requests per second, pushing that through the Teleport proxy perhaps isn't the best idea. In 2024, we are looking into kind of making Machine ID a little bit more about identity, not just for Teleport purposes. So at the moment, Machine ID does a really great job of, I want to connect out to, a database or an application or a Kubernetes cluster I have enrolled in Teleport, but it's not so great for, I want to use Teleport Machine ID to grant an identity that I can use within my own API. And that's something I'd like to look into in the future, because I think, again, this is a really tough problem space. And I think we can kind of bring our knowledge and our platform to help with that. But yeah, we'll see. Look to 2024 for that.
Very briefly, so we love Machine ID. We use a lot with GitHub. But I was wondering if there's any plans to allow users to bring their own OIDC token providers. So let's say we want to use it with something else. I know there's like Circle CI and a bunch of other ones, but if it's just, we have a key cloak we want to use to build tokens out of.
Yeah, so that's a really interesting one. So at the moment, those sort of like join token implementations methods are mostly using OIDC in the backend for that understanding of the token and how to validate the token. When we first added it, we did think of just adding a generic OIDC join method. The reason I held off of that at the very start is that it's very easy to shoot yourself in the foot. Because Teleport wouldn't have an awareness of the shape of that token coming in, it would be up to the user to write their own rules, and it is extremely easy to write a rule that means that anybody using that platform can suddenly authenticate, which is a worst case scenario. But keeping that in mind, it is something that's on my roadmap because, again, as you say, there's a bunch of IDPs out there like Keycloak, etc., where we can't really predict it, but it would be great for us to support it.
All right, cool, thank you.
Okay, awesome. Well, thank you very much. Feel free to reach out in Slack or even to my email, noah@goteleport.com, if you have any further queries or comments. Have a great day.